Hi everyone, this is Meena Seher. I'm a senior technical marketing engineer at Palo Alto Networks. And today we are going to be talking about Prisma SD-WAN and how this enables enterprises to understand application performance and troubleshoot issues and isolate them as quickly as possible. So, what are the primary challenges that enterprises are facing today? Branch office performance SLAs are not measured in terms of network layer performance. Rather, everything has gotten app-centric. So we are looking at application performance SLAs. Now, in order to measure application performance, there is no single yardstick. We need to understand how each application performs. Now, I want to emphasize on the word each because applications behave differently. So today, with the lift and shift of applications from on-prem data centers to private and public clouds, and with the increased consumption of SaaS application services for branch users, it is very difficult for generation one SD-WAN solutions to measure application performance because these generation one solutions are primarily bookended and measure just the network performance. So as I mentioned earlier, applications behave differently and they are also hosted on different platforms these days. So it's very difficult to use, or it would be inaccurate to use the same metrics, especially at the network layer, to measure application performance. We need something more, and we definitely need solutions that are not bookended. Because let's take, for example, Office 365, a SaaS application. Is it even possible for an SD-WAN vendor to put their own device or any of their endpoint device into the Office 365 cloud? That's impossible. So we need to come up with ways to understand application performance wherever that application and service could be hosted in. All right, so what do enterprise customers need now in order to measure application performance successfully? First of all, like I mentioned earlier, these SD-WAN solutions should not be bookended. We should be capable of measuring application performance wherever they are. And a real-time continuous performance monitoring is required in order to understand how applications are performing at all times. And if possible, using synthetic probing, we also need to understand application performance proactively. So in case there is a network layer issue or an application performance issue, we need to be able to understand what's actually going on in the network and not just wait for real user traffic to come in to understand the problem. Also, today we see enterprises having a very heterogeneous infrastructure. By that, I mean branch offices these days have MPLS links, broadband links, 5G cellular WAN links. There are mom and pop shops that just rely on cellular WAN links. There are pop-up branch offices that use 5G services. So it is important to offer this performance visibility consistently across all paths, across all applications, wherever they may live in. So with Prisma SD-WAN, we are able to solve all of these challenges for enterprises with the real user metrics that we collect, and also the proactive link quality metrics that we collect with synthetic probing. So I've just given here what all metrics that we collect and how we provide visibility into application and network layer performance. So now let's look at some specific use cases to understand how exactly we use these metrics to troubleshoot application performance issues. Okay, so now let's look at this example. So say, for example, branch office San Jose, users at this branch are experiencing slowness with web point of sale application. So the help desk tickets are coming in, and the network admin knows there are a million reasons why this application slowness could be happening. And most often we see that the network is very quickly blamed. There is congestion in the network, or we need more bandwidth. And why does this happen? Because there has been no visibility or no tools or no analytics that could give this segment-wise visibility that could tell a network admin where exactly this problem is happening. Now with Prisma SD-WAN, we have this visibility with all the rich app performance analytics that we collect. Now, if you look here on the Prisma SD-WAN dashboard, we measure the app response time. So we measure what you're looking at here is the RTT. This is the network layer transit time, which is basically the time taken for a TCP handshake to be established. And then there's a server response time, which is basically the time taken for the first response to come back from the server for a GET request sent from the client. And then there is a DNS response time. And then there is the entire network layer transit time, which is basically includes the entire data transaction time. Now, with these metrics, we are able to isolate whether this issue is happening because of DNS, or perhaps the issue is happening because of an underlying network layer performance issue. Or like in this example here, we see elevated server response time, which means the application web server is introducing latency here. The application web server is too busy to respond and is causing the actual slowness for the application. So as soon as the network admin logs into the Prisma SD-WAN dashboard and looks at the app response time for web point of sale, he is able to quickly isolate where this performance issue is happening. Why is this issue happening? And precisely he's able to say that, yes, it's the application web server that is introducing the problem. It's not the network layer. So that mean time to innocence for the network is very quickly established with Prisma SD-WAN. Now, this is not a benefit that enterprises can get from other generation 1 SD-WAN solutions, because primarily generation 1 solutions rely on network layer metrics like latency, loss, and jitter for measuring the application performance. And we know now that application performance we need visibility beyond the network layer in order to understand the true performance of an application. Let's look at another use case. Say, for example, voice call is experiencing performance degradation at a particular branch site. Now, this is an actual use case, an actual scenario that we saw at one of our customers. And they were having trouble for the longest time in order to identify a performance issue with voice calls, which were just happening intermittently during the day. Now, as soon as they deployed Prisma SD-WAN, they were able to see immediately with the media analytics that we collect that this issue is happening in the LAN to WAN direction, which means that all of the solutions that they were using earlier were primarily just looking at the network layer, the WAN circuit, and just saying that, okay, everything is looking good. So they were not able to find out why this issue was happening. But Prisma SD-WAN collects real-time media analytics, both in the ingress and the egress direction. So if it's the issue is happening in the ingress direction, the network admin can quickly say that it's happening in the WAN to LAN direction. If the egress metrics here show high packet loss or jitter, they are able to quickly identify that this issue is happening in the LAN to WAN direction, and they can immediately take remedial steps in order to fix the problem. Now let's look at another use case. SharePoint application is shown as experiencing poor application performance. Now, as soon as the network admin logs into the Prisma SD-WAN application dashboard, he does see that SharePoint is shown as an application that is not performing really well in the network. And that's also indicated by the health score for the application, which is fairly low. Now, the next question for the network admin: why is this happening, and which all sites are impacted with SharePoint application performance degradation? Now, as soon as the network admin clicks on SharePoint, he can see the impacted sites, and we see that San Jose branch site is impacted. So users at the San Jose branch site are experiencing some kind of application performance degradation, which is actually quite significant from the health score that we saw. And now the network admin can also see that for San Jose branch site, for SharePoint specifically, there are a high number of initialization failures, which means users at that branch office are trying to access SharePoint. Sometimes the application is unavailable. Sometimes it's okay. So there seems to be an issue going on here for users at the San Jose branch site. Now we need to know what's really happening at this branch site. Now, the network admin is on the San Jose dashboard. This is the site summary dashboard, which provides the network admin complete visibility into what's happening at this branch site. So we see here that there is one circuit here, which seems to perform poorly. So we have a circuit health score, which also indicates it's poor. Okay, so what's happening with this site? We need to know what's really going on with this site. Now, when we look at the circuit health, we see that Prisma SD-WAN has already assessed the problem. Prisma SD-WAN has already completed the troubleshooting, and it's providing guided recommendation to the network admin through the WAN insights. So these WAN insights are computed using AI/ML techniques, and Prisma SD-WAN is capable of doing packet trend analysis. It can study the trends that are happening on a particular circuit and provide insights to the network admin to understand what's really going on with this network with the guided recommendations. So as we can see here, excessive packet loss is detected, and the guided recommendation is to make sure that the circuit bandwidth is configured correctly. That could be provisioning issues, or probably there is an SLA issue with the service provider. So the network admin knows exactly what is the next step that needs to be taken in order to fix this problem. So with the visibility that we offer, the network admin is able to quickly detect the problem. Yes, there's a problem that's happening in the network. There's a problem that's happening with the application, and also deduce from there why that problem is happening. And not just that, the network admin also gets guided recommendation as to what should be done next to fix the problem. So this drastically brings down the mean time to resolve a problem. Now, if the network admin also wants to see per path visibility, so what is the help? There could be a single circuit, but there could be multiple VPN paths built on top of that circuit. All of these VPNs could be going to different destinations. Now, if the network admin wants insights at a per path level, that level of granular visibility is also offered on the Prisma SD-WAN application dashboard. All right, so now we looked at very specific use cases and how the application performance metrics that we collect can be used to identify where the problem lies. Now I want to talk to you about network events. So all SD-WAN solutions provide network events. There are several alerts and alarms that are generated. But how does a network admin manage these network events? So say, for example, there is a circuit flap that's happening at a data center, and that is going to cause a cascade of network events. Hundreds of alarms are going to be generated. Now, if a network admin has an email alert or a text alert set to alert him if an event like this happens, a circuit flap happens, please let me know. And if this alert reaches the network admin at 1 a.m., all that he wants to know is the root cause. Where is this issue happening? Why is this issue happening? How do I fix this issue? That's all the network admin wants to know. The network admin wants to know the root cause, not the hundreds of events that could mask a real problem that is happening. So with event correlation, Prisma SD-WAN is able to automatically correlate network events in the backend. And this does not require any manual configuration. We are automatically able to provide the network admin with the visibility into the actual root cause event that is happening, that is causing all this cascade of alarms. So we suppress all of those alarms. We correlate all of those alarms into one major network event and show the network admin just that event he must be aware of. So this is to make sure that actual network events that need the visibility and attention of a network admin are not lost in the cascade of network events that can get generated. Next, so we talked about event correlation. That's actually a backend process that happens automatically. Now let's say an enterprise wants to manage network events in such a way that certain events need higher visibility. Certain events need to be suppressed. How can they do that? So with Prisma SD-WAN, we have an event policy management solution where network admins can increase or decrease visibility or priority of network events based on the business intent. Example here, I have configured here an event policy where a BGP peer down event will be flagged as a P1 event. So say, for example, a data center device has a BGP peer down event with the core switch, basically the rest of the data center infrastructure, and that's a high priority network event. So now when I've configured this policy, this event automatically gets the highest visibility. So network admins do not have to settle down with the default priorities that network events come with. It's not a very rigid system. Network admins can manage network events in such a way that it aligns with the actual business requirements for the enterprise. I'll give you another example. An enterprise has 500 branch offices. There is one branch office, which is basically a C-suite exec office. And this branch office, there is a very high priority event that is happening. And any network performance degrading event needs to have the highest visibility from this branch site. How can a network admin do that? With the event policy management solution, network admin can configure a policy to provide the highest visibility or raise the priority to P1 for any network event that is originating from this particular branch site. So there is a whole lot of customization that a network admin can do in order to get the highest visibility for the network events that the business prefers. Similarly, the network admin can also choose to suppress alarms. Let's say maintenance window is happening. And we do expect certain scenarios like, say, for example, a network is going down, a device is going down. Why should a network admin get all of these hundreds of alarms? And perhaps an actual network event that needs visibility might probably be lost when an event like this, an expected situation is happening. So in that case, the network admin can create an event policy to suppress alarms when a maintenance window is happening at a particular branch site. Or say, for example, a network, a circuit flap is happening. And let's say the circuit flap is happening 5 times continuously in 5 minutes. In that case, the network admin can create a policy to make that a P1 alert. This circuit flapped 5 times in 5 minutes, and this is P1. So now the network admin knows that, yes, the circuit is not doing well, it's not meeting its SLAs, I need to go talk to my network admin. Similarly, a network admin can choose to escalate a standing alarm. So say, for example, a flap may not be a big concern to a network admin. So network goes down and then comes back up, it's okay. But let's say, for example, a BGP peer down event. It stays that way continuously for 10 minutes. That's bad. So so we all know sometimes a certain flap happens, circuit flap happens, the BGP peer goes down and then comes back up. But then if that situation persists, then the intensity of that event is going to escalate. So in that case, the network admin needs to have higher visibility of a standing event. So that's again something that can be done with the event policy. So with the event policy and event correlation solution that Prisma SD-WAN offers, network admins can be assured of getting the highest visibility for network events that matter to the enterprise, that are critical to the enterprise. Now let's look at IPFIX. So Prisma SD-WAN supports IPFIX, and we can export more than 16,000 flow information elements. And we can also very easily integrate with most of the third-party collectors, all third-party collectors, all network performance monitors that support standard IPFIX. Now, with the benefit of IPFIX, enterprises can receive raw flow data and use this data to monitor the branch office performance. And not just that, with traditional net flow, enterprises are just stuck to standard flow information elements like source IP, destination IP, source port, destination port, or the application. Now, with Prisma SD-WAN, like I said earlier, we collect several app performance analytics. There is rich telemetry. Now, it would be a great benefit for enterprises to export all of this telemetry, all of this visibility information that we collect from the branch offices, and export it to their network performance monitors, which can basically draw furthermore inferences on application performance or branch performance trends or app performance trends. So with IPFIX, this has been made easier, and now network performance monitoring solutions can also receive Prisma SD-WAN app performance telemetry through IPFIX. Now let's look at ops tools integration. Okay, so we talked about different ways to troubleshoot network issues, application performance issues. We also talked about how we can provide heightened visibility to certain network events or application performance events. Now, okay, so what do we do with these events? So most enterprises have operational tools like ServiceNow. So say, for example, a network event is generated, a critical event is generated, Prisma SD-WAN. Using our CloudBlades platform, we are natively integrated via API with ServiceNow. So what does this mean for enterprises? When Prisma SD-WAN has a network event, a P1 network event that's generated, the ServiceNow integration will automatically raise a P1 ticket, a critical ticket on ServiceNow portal. And let's say, for example, the network event is resolved on Prisma SD-WAN. The ticket status also gets updated automatically, and the ticket status is also resolved automatically. So with this integration, we are using ServiceNow. The enterprises that use ServiceNow as an operational tool are able to automatically receive network events and dynamically update the status as well on the ServiceNow portal. So this provides network admins visibility from all directions. Okay. Now let's talk about Autonomous Digital Experience Management, ADEM for short. ADEM provides segment-wise insights for hybrid workforce. So whether the user it's a mobile user, or if the user is working out of a branch office, we are able to monitor the user's application performance consistently. So what is different between the visibility that we offer with ADEM and the visibility that we offer on the SD-WAN application dashboard? So the SD-WAN application dashboard uses real user metrics. It's based on real users' traffic. With ADEM, it's synthetic tests. So we are able to proactively identify issues even before the real user traffic comes in. So this combination of ADEM and Prisma SD-WAN offers extremely granular visibility to enterprises with real user metrics as well as proactive synthetic tests. Now, we talked about heterogeneous infrastructure at branch offices. So there are several paths that are available for applications to take to different destinations. The path could be through Prisma access, the path could be a Prisma SD-WAN data center, or it could be a direct internet path or a direct MPLS path. So irrespective of the path that application takes, enterprises should have consistent application performance monitoring tools and mechanisms to understand how the application is performing on all of these paths. And ADEM provides that visibility for enterprises. So irrespective of whether the path is active or backup, we are able to provide that visibility on all available paths. And not just that, we also provide hop by hop visibility on all of these paths. Now, say, for example, we notice performance degradation on the internet path. So there's a service provider introduced performance degradation. Using path visualization, we are able to tell exactly which hop within the service provider network is introducing this performance degradation. So this provides actionable insights to the network admins as to where the performance issue is happening and how this issue should be fixed. Now, how does ADEM work? How to enable this service? The good news is ADEM is natively integrated within Prisma SD-WAN ions. By native integration, I mean it runs as a service, a backend service on the Prisma SD-WAN ions. So a lot of other vendors rely on container services, which need to be configured, provisioned separately, managed separately. So there is a significant amount of management overhead. But with the case of Prisma SD-WAN, ADEM is a native service, which means there is no management overhead at all. There is no requirement for any additional configuration or any IP address provisioning. There is no such requirement. The service just runs automatically as soon as the ADEM license is enabled. The service ADEM service kickstarts and can start providing visibility on all available paths for all business critical applications for the enterprise. And this service is available across the entire Prisma SD-WAN portfolio. There is no selective enablement for ADEM across branch offices. So this means an enterprise that wants these segment-wise insights across the enterprise or across mobile users, across branch offices for specific applications, it's just a single one-click enablement. And as soon as it's enabled, this visibility is available on all available paths, all applications, all users, all branch offices. And that brings us to the end of this session. Are there any questions that need to be answered?